That was that little bear in the picture blasting off, showing you that math will take you places. But in all reality, what we're going to talk about today is scientific notation. Talking a little bit how you can take really big numbers, like the distance it is from here to the moon, and making them in a little bit more reasonable format so that you don't have to write out really long numbers. That's called scientific notation. So scientific notation, with our goal today, it's to write, add, and subtract numbers in scientific notation. Now, scientific notation um, is a notation where you have it looks like this. So I'm just kind of skip around here. It's a number times 10 to a power. That front number has to be a finite decimal, meaning it has to end. It has to be between 1 and 10. So you have to have a number between 1 and 10, and the exponent has to be an integer. So for instance, like example 1 would be, because the first number is between 1 and 10, it's multiplied by 10 to a integer power. Whereas this one, exercise 5, would not be because 18.432 is not between 1 and 10, and 5 is not a power of 10. So there you go. One thing to point out with scientific notation or just powers of 10 in general, positive powers of 10 make a really big number. So if you have a positive power of 10, for instance, the second answer, we can look at it and we can already tell it's going to be a positive power of 10 when we write it out because it's a really big number. Whereas negative power 10s will be small numbers. So 3.25 times 10 to the fourth power. If we want to write that in standard notation, that actually, the trick here is, I mean, you can multiply it out, but the trick is to move this decimal just back 4 places. That negative 4 tells us to move it back 4 places. So we have a point, and then we fill in the 1, 2, 3 zeros. So 0.000325. That's what that number actually is. We don't have to write it that way. We can write it in scientific notation, which is a commonly used notation in science and in a lot of different branches of science and math. All right, now 16. Now we're going to go backwards. We got 16 million. We want to write that in scientific notation. So the first number we want to be a whole number between 1 and 10. Well, it doesn't have to be a whole number. It just has to be between 1 and 10. So to put this decimal place, we're going to put it between the 1 and 6. Because that's the only place that'll make a number between 1 and 10. So we'd have 1.6 times 10 to a certain power. Now we're going this way again. Now let's check how many places the decimal is from where we're putting it from where it should be. So it's 1, 2, 3, 4, 5, 6, 7. And it's a positive 7 because it's a very large number. And also to get back to that, we'd have to move it 7 to the right. So that would be our scientific notation for that one. Now we're going to focus on the main thing, which is adding and subtracting in scientific notation. So adding and subtracting in scientific notation. Let's look at this first example, number 7. It says we have a table here with the 3 most populous states and the 3 most least populous states. So these are the 3 most populous states. And these are the 3 most least populous states. So letter A, it says, what is the sum of the debts for the 3 most populous states? Express your answer in scientific notation. Now, those are big numbers. We're looking at the debts. So let's take them all and write them in scientific notation. So the first one, 407 billion, it looks like. 407 with 9 zeros. We want to write that decimal so that it's a number between 1 and 10. So we're going to put that decimal here. So it's going to be 4.07 times 10 to the, well, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to the right. It is a big number, so it is a positive exponent. Let's do that with the other 2 as well. So the 3 most populous states, New York, so 337 billion. Now for that one, we're going to put the decimal after between the 3, so it would be 3.37 times 10 to the, that is also going to be the 11th power. And last one, Texas is 276 billion. All right, with that one, we're going to move it so that it's 2.76 times 10, and that'll be to the 11th power as well. Now, if we want to find the sum of all the debts, we want to add them up. So that's adding. So our trick with adding, I'm going to pull this out here, and you can copy this down off to the side if you'd like. This will be helpful for adding or subtracting scientific notation. You need to first make sure that both or all the powers have the same power of 10. And these actually, they all do. They're all to the power 11. So we're good there. Then we want to add or subtract the front numbers. So let's do that. Let's add or subtract. Let's add the front numbers. So if I add these front numbers, I get 20, carry the 2, 12, carry the 1, 10. So I end up with 10.2 or 10.20. Now it says keep the power of 10. So we're going to keep it as times 10 to the 11th power. We don't have to do anything with those powers. And then number 4, adjust decimal and exponent if not in proper scientific notation. Okay. It's not in proper scientific notation because we don't have a number between 1 and 10 here. So to do that, we have to move it back 1. So it's going to be 1.02. And that's going to actually add 1 to our exponent. Because if we want to get back to 10.02, we would need a positive. Okay? So we'd have to go bigger. We'd have to have a bigger exponent. Okay? So it's 1.02 times 10 to the 12th power. That is the debt. All the debts. So what I'd like to do now is to do it with the least populous states. We're going to do the same idea. So I'm going to rewrite those numbers in scientific notation. So I have 4, nothing after it, times 10 to the 9th power. North Vermont, I've also got 4 times 10 to the 9th power. And then Wyoming is going to be 2, and it's times 10 to the 9th power. They'll each move over 9 places. So to add them together to find the sum, we add up the numbers in front. So that gets 10. So we'd have 10, and we keep the exponents the same because they're already all the same, times 10 to the 9th power. Now our first number isn't between 1 and 10. It's too big. We can't have the double-digit number, so we have to move it so that it's right here. So we would have 1, or 1.0 times 10, and that'll bring us up 1 to the 10th power. All right, last thing with this. It says, how much larger is the combined debt of the 3 most populous states than that of the 3 least populous states? So to find how much larger it is, we'd have to subtract. So what we're doing is 1.02 times 10 to the 10th power, or 12th power, minus 1 times 10 to the 10th power. Now, if you recall before, we can't add or subtract unless there is the same power of 10. And since these don't have the same power of 10, we have to make them that way. So the easiest way to do that is to change the second one to make it bigger. So if we want to change this to become a power of 10, it's going to be a power of 10 of 12. We need to move that decimal back. So we're going to move it back 2 places. So it's going to be 0.01. Okay, now if we move it 2 to the right, that would take away 2 of the exponents, so it would be back to 1 times 10 to the 10th. But we want times 10 to the 12th, and that's okay if it's not proper scientific notation for the sake of subtracting. So we would have, this stays the same, it's 1.02 times 10 to the 12th power. And, whoops, move that back. Now we can subtract. So I get a 1, I get a 0, 1.01, and I can keep the power of 10 as 10 to the 12th power. And that is proper scientific notation. So it's a little bit tricky when we have to change it, but that's the big difference here. So what I'd like you to try is go to number 8. It's based off of the same chart, but now we're dealing with the populations. So you're going to practice exactly what we just did there, only with the populations. So why don't you pause the video now, try this, and you can unpause it and then check. Alright, to quickly explain what I did, I changed them all to scientific notation in A for the highest population ones. I added the front numbers and got 8.3, and I kept the base, or the power of 10 to be 10 to the 7th power. So I got 8.3 to the 10 times 10 to the 7th power. Now for the second one, I wanted to show you a different way, just because 690,000, those three numbers, they're not huge numbers. So what you could do is you could add them all up normally, like I did over to the left here. I got 1,892,000 as a total, and then you could change that to scientific notation. So it's just a different route when you have maybe not such huge numbers. I got 1.892 times 10 to the 6th power. And since the last question asked us to figure out how much bigger it is, I'm going to change that. It does say how many times greater we would divide, but we're going to do how much bigger, just because that's what we're working with. How much greater. So we would subtract. And I'd have to change the bottom one so it's a power of 7. So it becomes 0.1892 times 10 to the power of 7. And when I subtract those two numbers, I get 8.1108. And then I keep times 10 to the power of 7. So that would be adding or subtracting scientific notation. And that's really what I wanted to focus on, is the brief intro to what scientific notation is for writing it, and then adding and subtracting. So there you go. Have a great rest of your day.